A very good morning to one and all. My name is MSS Bhargav. I am from Electronics Department, BV Raju Institute of Technology. Today I am going to discuss a small topic in the concept subject called microprocessors and microcontrollers. And in that particular topic, I am going to discuss 8051 microcontroller, its features, and the pin description. So, coming to the topic, 8051 microcontroller is otherwise called as computer on a chip. As computer is a simple definition as a central processing unit electronic device consisting of central processing unit with input and output devices alongside with the memory. So, a general purpose computer which does kind of storing different files, playing video games, playing video files, and a system developed using 8051 microcontroller also acts as a small computer. Here, coming to the features of microcontroller 8051, it was designed by Intel in 1980s, and in 1970s prior to 8051, microprocessors were mainly incorporated in large of embedded systems like calculators, video games. And with the introduction of microcontrollers in 1980s, 8051 prominently played its role in designing different applications where cost and performance is much more crucial parameter. So, 8051 microcontroller is a 8-bit microcontroller which it has internal bus, data bus, which is of width 8-bit, and internal address bus is 16-bit, and the data bus is 8-bit. It is an 8-bit microcontroller. That means it can perform 8-bit operations in a single instance or a single clock pulse time period. So, it has 8 data lines and 16 address lines. And also it has on the chip memory both ROM and RAM. Read-only memory, which is otherwise called as program memory or code memory, and RAM, which is otherwise called as data memory. Code memory is of size 4 kilobytes and data memory is of size 128 bytes. So, it is having on the chip memory in the form of ROM and RAM. So, it has another peripheral devices like crystal circuit oscillator, and also almost the crystal oscillator frequency is around 12 megahertz. And another one of the important feature of 8051 is it has a rich set of registers where the primary and highly prioritized register is accumulator, as you already know, as the microcontroller 8051 is 8-bit in performance, and the accumulator A is also 8-bit and followed by B register, and another set of special function registers are there, mainly controlling different on the chip operations. So, additionally there are registers A, B and special function registers, as I said earlier. And now, in order to operate and control the operations of different on the chip peripherals, there are some peripherals which is present on the chip of 8051. It controls the operations of these peripheral devices are controlled by the special function registers, as I told you. So, it has two timers. It has two timers, timer 0 and timer 1, which is of size 16-bit, and it is also having on the chip USART circuit in order to enable serial communication with outside devices. and it has 4 ports. It has 4 ports. So, to be precise, it is an 8-bit microcontroller. The data bus is 8-bit, address bus is 16-bit, and it has on-the-chip memory in the form of ROM and RAM. ROM is of size 4 kilobytes and RAM is 128 bytes. And along with it has 2 timers, 16-bit of size each, and registers are accumulator A, B register, and special function registers we will discuss thoroughly in the next lecture. And it has also having USART, universal synchronous and asynchronous receiver transmitter circuit, mainly used for serial communication, and it has 4 ports, mainly used for parallel communication. It can be used for serial communication and parallel communication. Port 0, port 1, port 2, port 3, and port 4. So, as I told you, it has 4 ports, that is parallel ports, as I meant to say. It has 4 parallel ports, namely port 0, port 1, port 2, and port 3. All are of size 8 bits. 8 bits. All are of size 8 bits. So, by the presence of these ports, we can establish communication with the external devices. We can communicate or interface any keyboard, any display device, any stepper motor to control the direction of the motor. You can externally add the memory. If the internal memory is used excessively, we can also externally connect interfaceable memory. So the ports are used for connecting or establishing communication with the outside devices or outside world. So existence of the ports is one of the profitable parameter in the case of 8051 microcontroller. So, with its powerful CPU, integrated RAM and ROM, and I/O ports and timers, 8051 microcontroller is capable of executing different wide variety of communications and tasks, and do some simple control systems to design a complex embedded application. So this is how 8051 is versatile when compared to its predecessor 8086 microprocessor. So coming to the next topic, that is the development and the history. It was, as I told you earlier, it was designed by Intel during 1980s, and significantly its incorporation in developing embedded applications, it is widely used in a lot of embedded applications where cost is and performance and size, where these are the main design metrics. Keeping in mind these design metrics, when these design metrics are given high priority, the designers opt 8051 as a core commercial processor in order to design an embedded application. And it came also after its inception in 1986, and again over the years it was evolved, and lot of versions of 8051 based on the main architecture of 8051, lot of architectures, newly refined architectures and evolved and enhancements came to this kind of basic 8051. So mainly these 8051 based embedded applications, whatsoever 8051 microcontroller used, mainly it is used in automobiles, industrial controls and consumer electronics. So this is precisely the history and the upcoming evolution of 8051 microcontroller. So as I told you earlier, the features and the architecture of 8051 is nothing but the detailed data flow of the data coming inside from a memory, and how it is going to access or moved inside the memory from registers to CPU, the processor, and how it is executing the data received, and again how it is restoring or writing the data, whatever the operations it has done, arithmetical or logical, how the data are stored onto the memory. So the architecture of 8051 here, mainly the architecture is based here there is a memory architecture 8051 follows, which is 8051 follows Harvard memory architecture. Harvard memory architecture. That means ROM, which I told you, which is called as program memory, and RAM, as I told you earlier, which is called as data memory. Both has different address spaces. Let me clearly explain the concept of Harvard. There are two different kinds of memory architectures in the case of microcontrollers. So one will be Harvard and another one is Princeton, also called as von Neumann architecture. So von Neumann is a scientist who worked at Princeton University, and another architecture was developed at Harvard. So Harvard memory architecture is incorporated in this Intel 8051 microcontroller. So Harvard is nothing but there is separate address spaces for both ROM, program memory, RAM, data memory. So already on the chip it has 4 kilobytes of ROM, as I told you, and 128 bytes of data RAM it's present. So it has its own address spaces that different memories will be there and addresses will be there. Starting address, hexadecimal address 00H to 7FH, 127 memory locations, as this one, and this one is 4 kilobytes. So this one is 0000H is the starting address, 01FF is the ending address of internal ROM. So as I already told you, the internal data bus is of size 8 bit data bus is present. That means 8 data lines is present, and 16 bit address bus is there. That means 16 address lines are there. 16 address lines are there. That means the maximum memory that 8051 can interface will give you 2 power 16. That is the addressing capability. The maximum memory that 8051 microcontroller can interface both externally as well as internally. That is equal to 2 power 16. As the addressing capability, it is called as the addressing capability, that is equal to 2 power 16. That gives you simply 64 kilobytes, where kilo in computer terminology is 1024 bytes. That means 65536 bytes. 65536 bytes. That's the memory we can interface. So the maximum memory we can interface is 64 kilobytes. But we discussed that the internal ROM is 4 kilobytes. Already 64 kilobytes is the maximum memory. Out of that, 4 kilobytes is already on the chip, it is present, and 64 kilobytes. 4 kilobytes is already present, and the externally maximum memory that we can interface is 60 kilobytes. So that does not exceed the addressing capability or the range of addressing capability of 8051. So these particular features and the architectures helped 8051 to get involved in application or applying or developing different projects at diverse electronic projects. So moving on. So this is a precise and then clear-cut diagram of the pin diagram of 8051. 8051 is a 40-pin IC. The packaging is dual inline packaging, where it has 20 pins on one side and 20 pins on other side. You can see clearly on the diagram. So out of which it is clearly mentioning that there are 4 ports: port 0, port 0, port 2 on the right hand side, and port 1 and port 3 on the left hand side. And port 0, port 2, mainly we have this one is mainly 8 bits in size. 8 port pins are there, out of which here generally it is used as normal bidirectional IO port. Bidirectional IO port normally. When external memory is interfaced, it contains lower order address bus and lower order data bus multiplexed to each other. That means AD0 to AD7, it is present on port 0, and port 2, some majority of the time it is normally used as an IO port, and higher order bus is present on this particular bus, that port, that is A8 to A15. So overall address lines are 16, as we discussed, A0 to A15, and D0 to D7 is the data lines. Lower order address and lower order data bus are multiplexed, and it is present here on port 0, and port 2 contains higher order bus. On the other hand, port 1, it is simply used as IO port, where we can connect IO devices, and port 0 and port 2 we can connect memory most of the time, and sometimes IO devices also. And port 3, on the other hand, it is having it does function as a normal IO operations, used for normal IO operations, and sometimes it has a special functions where port 3.0 it is used as receive data, and 3.1 as transmit data. That means these two lines are meant for serial communication. Let me explain you clearly. These two lines are used for serial communication. Port 3.0, port 3.1. Port 3.0 and port 3.1 are for serial communication, for serially receiving data and serially transmitting data. So 3.1 is used for serial transmission of data, and serial receiving data is taken at port 3.0. So, and port 3.2 and 3.3 are interrupt pins, where external devices can send interrupts to this particular port pins, and the 8051 CPU can get interrupted by the external devices through these pins. And timer 0 and timer 1 are connected to port 3.4 and 3.5 pins. And memory read or memory write operations, we can send, or we can send a control signal like WR, where it is called as write, and read bar. These two write and read operations are done. We can use memory read as well as memory write. And for IO operations, IO read and IO write. So that is the main function of read bar and write bar, which is our port 3.6 and 3.7 port pins. So apart from these ports, 0, port 2, port 1 and port 3, we have the chip power supply, that is 40th pin, that is VCC. A CMOS voltage is 5 volts, and this one is ground, and 18th pin and 19th pin externally there is we can connect a ceramic resonator, so that it will act as a clock circuit. It will act as a clock circuit. So the clock frequency, or whatever the frequency the ceramic resonator is resonating, the frequency of clock is generated. The general operating frequency of 8051 is 12 megahertz. So this is the detailed and description of all the port pins, and there is a special 3 ports are left over, which is called port 3.2, port 31 and port 30, port pin 29. It is there. So it is called as program store enable port 29th pin. So 29th pin is called as program store enable. It is used, if it is enabled, we can access external connected ROM, and port pin, that is 30, it is called as ALE. That means it is abbreviated as address latch enable. That means as port 0 is having multiplexed address and data. When memory is connected across port 0 and port 2, this port 0 is having multiplexed address and data lines. So when ALE is equal to 1, the bus connected to this port, it is having address. When it is 0, the bus will be having data. That means it separates the bus being from address bus and bus being from data bus. So ALE is equal to 1 means the bus is acting as address bus, and ALE 0 means the bus is acting as data bus. So address latch enable distinguishes from what is present on the bus, whether it is address or data. So that is dependent upon the value of ALE. As I told you, 29th pin is called as program store enable, that is for external access of ROM, and ALE is nothing but distinguishing the values, that means address or data on the bus. So, and 31 pin which is left over, which is our 31th pin is EA bar, which is external memory access. In order to access any external peripherals like memory or IO devices, this pin must be enabled. As it is an active low pin, logic 0 is written to this particular pin in order to get 31th pin, which is EA bar, to get enabled. And active low pin is also there, that is here our PSE bar, and lot of active low pins are there here also. Read bar and write bar, these are active low pins where logic 0 is written to these pins in order to activate or enable the functionalities of the respective pins. So this is the detailed information of the pin diagram of 8051 and its features. I hope you like the video, and see you in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.